We're out at one of our front beach houses on Isle of Palms, and I wanted to take a moment to just talk a little bit about how we build in this coastal environment in the Lowcountry. It's challenging, to say the least. Right now it's summertime, it's August, we're getting up into the high 90s, humidity's really high, we have the salt air environment hitting the house, and our goal is to try to find a way to build this to withstand generations of time, low maintenance, and allow the family to really enjoy their time here. So let me point out a couple things that we've got going on that we're using. This siding right here looks just like cedar siding, paints up real well, but it's actually new cedar. It's a PVC product that we've been putting on the houses. Stands up really well in this weather. If we use real cedar out here, it cups, it buckles, it starts to bleed a little bit over time. So this is a great product to use to stand up to the salt air. Even our trim is all composite, so that we don't have to worry about wood on the exterior of this house that's going to move a little bit with the moisture problems that we have. Another great thing that we do that not many builders do, if you look down here, you're going to see the silver stuff on the house. This is a rigid board insulation that we put around the entire outside of the house. So we have an entire thermal break on the outside. And the reason we're doing that is because here in the Lowcountry, with this really hot outside air that we have, hot and humid, and then we're going to try to make the inside nice and cool and dry, we're going to try to ask this wall cavity that's 6 or 8 inches thick to try to control that temperature change. And in this shot, you can probably see a few really large doors, some really big windows. We're not only in a hurricane zone, but we're also in a seismic zone. So inside this wall, that maybe we'll show you in a little later, this is solid wooden steel. There's nowhere to put insulation in that corner. There's nowhere to put insulation in this entire wall from end to end. So as a result, we're insulating on the outside. And we're making that thermal break so that we keep all the hot, humid, moist air to the outside of the building. And that way we can control the environment on the inside really, really well. And that creates a nice, healthy home, not only energy efficient, but healthy. Cuts down on all the mold and mildew problems inside the house, as long as we plan out the HVAC system correctly, which at some point we'll talk about with you on another video. We've jumped inside this house now, so I can show you a little bit about what we were talking about with that rigid insulation. You can see it through the window out there below the siding. You can see that this corner is just solid wood, and actually inside of that is steel. Like I said, there's no way to insulate this with anything. We can't use foam insulation, we can't use fiberglass insulation, so that's one of the reasons we've really moved to the rigid board insulation on the outside of the house. But the other piece of this is air sealing. We really cannot have this hot, humid air come into the building. So we do a really good job trying to seal the exterior of the house, and we use, like normally installing windows, we use this nice MP1 sealant on the outside. Well, we also run it on the inside. You can see it right here, this gray caulking that goes down. We seal all the way around all of the doors and window units throughout the entire house, so that there's no way air is going to penetrate past this window unit and get to any of the interior trim that's going to go on the house later. Our real goal is to keep all that hot, humid air out and keep this nice dry air on the inside. And soon we're going to be doing the blower door test on this house, and we do it at this stage once all the rough-ins are done, and before we insulate the walls, we actually negatively pressurize the house and literally try to suck in air from everywhere. And we do it at this stage so that way we can go around the house, and if we find air coming in, we can seal it up and make sure that no outside air is coming in. The planning that goes into building a home like this is really, really critical, and we do so much ahead of time on paper before we even get to the stage of putting this house up. One of the major things that we're always looking at, right now I happen to be standing in the kitchen, the range will be over here, you can kind of see the range hood duct that's coming through the ceiling. One of the things that we're always focused on, of course, is a lighting layout around the kitchen, making sure that the lights are in the right locations. That's going to be really critical to the client, as well as shade pockets and all of the other things that we need. But hidden in this floor system, of course, we have plumbing and HVAC. We've got electrical wires. Electrical wires are pretty easy to move around. Plumbing and HVAC is not. So a lot of the planning that goes in on paper with our structural engineers to try to figure out how we're going to get the ductwork through the building so that we can maintain all the visual stuff afterwards in the right location. So if we look up here, we've got steel columns coming down supporting this big LVL. Up here that is that laminated beam that the floor joists are running into. And you can see this ductwork runs right through the middle of it. And usually you can't cut through one of those beams like this. So we've worked with our engineers to figure out steel plates that will go into that beam to support it. You can see all the bolts coming through that are going through the steel, and everything's sandwiched up there so that we could cut this big hole and send the ductwork through it. In this house, we also have actual steel web trussing. We have I-beams and all the planning that had to go in to get the steel cut so that we would have holes in the steel where the ductwork can go through. So it is hours upon hours worth of work on paper in order for us to make sure that once we get to this point of framing the house up and running ductwork through, everything goes exactly in the right locations that we want it to go so that plumbing can run out clearly, the lighting layout can be maintained, automatic shades or drapes that are pocketed into the ceiling are all done correctly. And it really comes down to early planning so that it makes it easy once we get out here on the site. I want to talk to you about this color coding that we use that you see behind me. You can see the yellow on the bottom plate of this wall. Over here you can probably see a little bit of green going down this hallway. And if you look through this wall, you can see some blue in the back wall of the house where the windows are. All of this color coding is to help our team and our subcontractors understand what is the final material going onto these walls. So in some cases we have wood walls, some cases we have plaster, some situations are tile. So all of those different type of wall materials have different thicknesses and different applications for what we have to do when we're prepping at this stage with our rough-in team. So right here, you can see the yellow. This is going to be plaster walls. That's what the yellow is indicating throughout the house. And so as a result, the electrical boxes down here that are going to be in the baseboards have to have a slightly different thickness than if it was just straight up drywall. The blue in the back is tile. So same situation. We always obviously put up sheetrock and everything first, and then you're going to tile this wall. The wall becomes a little bit thicker, and it's different than the plaster wall. And then the green walls, or the green over here, is regular sheetrock. And other parts of the house, you might see a different color if we have wood on the walls. So it's all in the planning stages this early on to make sure that each wall is custom built with all the electrical boxes, the plumbing fittings, everything that's going and going to be hidden in the wall is set to the right dimensions so that when the finish crews come in and start working, we don't have to open a wall back up to adjust these things back and forth. It's all planned out and done ahead of time. We're upstairs now on the second floor porch, and the materials are slightly different. They're also painted at this point up here, so at least most of it is. But I still wanted to point out a little bit more about the coastal materials that we're going to use. This is all a product called Boral. It is a fly ash product that is great for the coastal environment. It does not absorb moisture. You can see the original color of it down here. But it'll really hold up and won't move very much with our moist environment. But the one wood that we do use consistently on all of our houses is the deck boards that you're looking at. This is real wood. This is called Ipe. And we found that from a maintenance perspective, as long as you don't want to stain it or finish it, this is one of the best woods for our particular coastal environment. It will gray out a little bit like teak does, but it will hold up perfectly, and you just need to kind of clean it with a deck brush, kind of like on a boat. You might scrub the teak deck down on a boat. This is very similar. That's about all you really need to do. So a little bit of just cleaning the dirt off is the only maintenance that Ipe needs, as long as you don't want to try to stain it. If you want to stain it, it's a tremendous amount of work out in the sun. But otherwise, it looks beautiful. Most of our clients use it up on the second floor, oftentimes first floor as well. This particular deck, since it is on the second floor and we have porch below, there is a waterproof deck that's underneath here. And the waterproof deck is pitched so that if water gets through the decking here, it goes below, it's all caught, goes out to the gutter system when it rolls off the porch. But we're able to level out the epay so that way, when you're out here walking around or you have your chairs and your furniture set up, you're not worried about tables rocking and moving as the deck boards are pitched. So the epay is very close to being level, but below that is a pitched waterproof deck that takes the water out and off the building. Well, as we've talked about, building in the Lowcountry is really fun because we have all sorts of different challenges. We've got potential hurricanes, we have seismic activity here in Charleston, so the building structurally has to be built really, really sound. But because of our hot, humid environment, we get thunderstorms every afternoon in the summer, and sometimes they're pretty severe. So one thing that most of our clients will do is install a lightning protection system throughout the house, and that's what you're seeing that was sort of cut into this column right here, or this pier, is the copper wire that runs all the way through. It goes all the way up to the top of the house where there are literally lightning rods that will stick out the top of the house. And then these guys come all the way down and they're grounded straight into the ground. So the concept here, this is really more of a life safety type lightning system. You know, worst case scenario with a lightning strike is that somehow a fire starts in the house, and then of course you're trying to get people out at that point because the house is on fire. So this system is designed to take the lightning down and out the outside of the building, and with any luck, make sure that a fire doesn't start in the house. It is possible with any lightning strike, and with all of our computer chips that we have in just about every single piece of equipment that runs inside the house, you could still get the surges that happen that knock out a motherboard in a refrigerator, an HVAC system, something like that. Along with this system, there are tons of surge protectors put throughout the house. But you know, lightning strike is so large that it can overwhelm just about anything. So the real goal, again, is life safety. We're trying to keep the house from catching on fire. We're trying to make sure that the residents that live in here are safe throughout any of these big lightning storms that happen.
Thank you for watching. For more videos on building science, please subscribe to our channel.